Good day and welcome to today's lesson. Today is going to be a recap of what we have done for the past 4 days. So basically, we try to remind ourselves of what we have done. Okay, so without wasting much time, let's get going. Yes, you remember we started the week with the concept of diffusing, uh, and then we went on to talk about uh, heating and cooling, and we did also talk about what density. So let's get going. So we said, in what way do the particles of liquids and the particles of gases behave in a similar way? And then our answer was that the liquid particles and gas particles are able to move what freely. All right. So let's look at diffusion. We said diffusion is a process in which the particles move from a highly concentrated area to an area with a lower concentration of those particles. All right, and we said diffusion only takes place in what? Liquids and gases. And then we said concentration refers to the number of particles in a certain area. A higher concentration contains many particles, and a lower concentration contains fewer particles. So if I may put this into perspective, this kind of concentration. So let's say I have got two cups of water, the same water, and then in one of the cup, I pour in what? Three teaspoons, and in one, I pour in what? 2 teaspoons. Obviously, which one is going to be concentrated? It is the one with 3 teaspoons full. Okay, so that is the concentration, number of particles in a certain area. So if you look at the three teaspoons with sugar, so the number of particles per volume in that cup, we will be talking about the concentration. So if the three teaspoons of sugar will taste sweeter than the one with two. So that's just the concentration in terms of particles that I just want to illustrate. And we said diffusion is faster in gases than in liquids. All right. Then we said gas particles move quickly and at a greater space, and therefore they will move quickly from a higher concentration area to a low concentration area. And then we're saying the speed at which particles diffuse depends on the what? Size of the particles. So the state of the particles, and then the what? The temperature of the particles. So it means these are conditions that affects what? Diffusing. So the size of the particles. The smaller the size, the faster the diffusion. Then the state of the particles. Is it gas? Is it a liquid? And the temperature. Is the temperature hot or cold? All right. So let's go on. So we say in diffusion, so as we have just explained more conceptual development, so we say diffusion is a process in which the particles in liquids and gases move from a place where there are many particles to a place where there are fewer particles. So you remember I told you that if you are at one corner of your room and you're having a spray or a perfume or an aerosol, and then you press and you spray. So where you are standing, the particles are more. So after some times, you see that if somebody is standing at the other end, the particles will begin to move to this one where they did not spray. So virtually, you are seeing that the particles are moving from concentrated area to a less concentrated area. Okay, so and we said diffusion only occurs in gases and in liquids. It doesn't happen in what? Solid. We said the particle model of matter explains what diffusion. And we said diffusion occurs because particles of matter are in continuous motion. So because particles are in continuous motion according to particle model, then diffusion can occur. So diffusion takes place faster in gases than in liquids because the particles in a gas move quickly than the particles in a liquid. The rate at which diffusing particles diffuse depends on the size of the particle, the state of the particles, and the temperature of the particles. All right, I'm coming with a question now. Okay, before I explain this slide, I want you to mention the factors that affect the rate of diffusing of particles. You can mention one or two or three. Mention any factor that influences the rate of diffusion of particles. Let's get going. Hello, my beautiful learners. I hope you are listening. Yes. All right. We might do Kahoot if we finish what we are doing. Yeah. So work out if we finish what we are doing first, we will do Kahoot or Kahoot. Uh, Lynn, I'm not. We are looking at factors. So look at your answer. Those of you who are asking whether we are doing Kahoot, yes, we might do Kahoot, but depending on what we have. If we finish up and there is time, we will play it. I'm always doing it for you people to get interested and learn as well. It's a game of ideas and learning. Okay, so my question is, mention the factors that affect the rate of diffusion. Mention the factors that affect the rate of diffusion. Let's get going before I explain this slide. Oh, okay. I want to do you people a favor. I'm going back to the previous slide. Okay. The question I've asked is somewhere here. So briefly get it for me before we move quickly. If you don't answer it quickly, it might hinder our playing Kahoot. So I said, mention the factors that affect the rate of what? Diffusing. We mentioned three, and I said mention any of them. Okay, very good. Lisan, you are correct. Yes, the mass of the particles, perfect. Workhouse, you are correct. Size of the particles, short one, short one, short one, short one. Princeton, you are almost there. I want you to reorganize your answer. Princeton, adjust your answer. Perfect. Somebody has said it. Yes, temperature of the particles. That's fine. The answer was on the last point, F. The rate at which particles diffuse depends on the size of the particles, the state of the particles, and the temperature of the particles. I hope you got that right. Thanks very much. Then let's move on to the next slide. Then we said gases, diffusion. Have you ever noticed how quickly smells travel? Perhaps you have walked past a rubbish bin and smelled the garbage. Hey, it smells bad. Hey, you can often smell garbage bins when you walk past them. Has anyone ever set off a stink bomb near you? Very bad. Now, yes, this is just all what the experiences, if you have got them, all is due to what? Diffusion. Okay, these experiences are, the smell is always very bad. Okay, now let's go on. So, diffusion. What will the mixture look like when the color particles are uniformly spread out among the water molecules. I'm asking a question now. My dear learners, let's look at the picture or the diagram on the slide. I have got two things on the left-hand side, two sets, but there are four glasses. The first ones, you see that the water is having a liquid colorant. And then, yeah, what is going, okay, I have seen somebody's responding very good, yellow. So you see on top, immediately you drop the food coloring on top. Now the top there, the particles of this color is concentrated at the top. You can see. Then the particles then begin to move to where the particles are few. Then you see the second, this beaker is showing you that it's moving. Then this movement of particles will continue until the whole of the liquid is yellow. You see that? Okay, so the answer is perfect. Now, what happens? What happens to these particles? This is the explanation that is on the right-hand side. A particle in a liquid cannot travel very far before colliding with another particle because the particles are so close together, so you can see. Yes, that means that the liquid particles are constantly colliding and are sent into a new direction with each collision. So what it means is that if this one is moving into the northward direction and then another one collides with it, it can change to the east, to the west, or to the south. That's what they mean. It means this sentence is say the sentence says that means that liquid particles are constantly colliding and are sent into a new direction with each collision. This means that the rate of diffusion is much slower in liquids than in gases. You see, why is the rate of diffusion slower in liquids than gases? The fact is that they collide, and as they collide, their speed is decreased or hindered. All right. That's why the rate of diffusion is much slower in liquids than in gases. Because the particles of gases are further apart and collide much less, gas particles travel further without being sent in a different direction by collision. This is why gas diffuse more quickly, as we can see. So you see, liquids, the particles are what? Close. So gases, the particles are what? Not that close. They are far apart. So they don't easily collide with each other as compared to what? That of liquids. So what happens is that liquid diffuse faster because there is less collision. And because there is less collision, they are free to move to wherever they are going. If this one is moving northwards, it will continue moving because there is less collision. But liquids, there is more collision. So hence, diffusing in liquids is less compared to that of what? Gases. So this diagram is just illustrating what we have done here. So if you look at this color, we can actually represent, we can say liquid. That is what is the particles of this color in water is busy behaving this way, as we can see. Yes. So you can see it started going this way, then it changed direction. It changed direction. It changed direction. But if you look at what the gas particles, the change of direction is not much. So that's why they travel fast. Okay. All right. So let me ask a question. Can somebody explain to me why gases diffuse faster than liquids? You can explain it in your own ways, my dear learners. Yes, my dear learners, send in your response. I can see somebody already coming with the response. Yes, Princeton, that's a very good start. So continue, finish it up. I am saying why gas particles are diffusing faster than liquid. So you have just said one portion of it. So try to complete it up with the other portion. So it means we are comparing. So you have just mentioned, you have made a statement referring to only gases. So complete your statement and it will also refer to what? Liquid. Princeton, I hope you get me right. Okay, that's good because you have come with also, that's a very good attempt. Perfect. Please send in your answers. Yes. Okay. Yeah, I can see the responses. All right. That's very good. All your answers are good, meaning you understand what we're talking about. So let's quickly move to the next so that we can beat time for me to satisfy you people playing Kahoot. Then let's look at the factors affecting diffusion. So we said factors that affect the rate at which the particles diffuse. One, we're talking about the speed at which particles diffuse depends on several factors, namely the mass of the particles. So it's going to be explained here. Lighter particles will diffuse faster because on average they move faster. So it's just like we are comparing if we have got these big trucks that convey these checkers food from one place to another. If you compare that, the look at the size, sometimes you even have three or four, two or three trailers combined. And then if you having only one a private car, let's say a city golf, you see it's very small compared to that. So you will find out that the city golf will move faster. So when we compare the mass of the particles is the same thing. So if the particle is big, it means the movement is less. And then if the mass of the particle is small, the movement is more. So that's what it's saying. Lighter particles diffuse faster because on average they move fast. So we have explained that. Now let's look at the state of the particles. What do we mean by that? The state of the particles. The particles in a gas are always moving fast. So we say their average speed is high. The particles in a liquid travel more slowly. Okay. So if the particles are gases, they travel faster than if they are what? Liquids. Okay. Then the temperature of the particles explained here. Temperature is a measure of the kinetic energy of the particle. The higher the temperature, the more energy the particles have, and then the faster they move and diffuse. Very good. So you take note. Um, take note of this place. If you are asked to mention the factors and explain them, this is a perfect slide for you uh, with regards to the explanation. Then we said the size of the spaces between particles. If there are large spaces between the particles of one substance, the particles of another substance can move into those spaces easily. Okay, so you see, so you can see that we have got, if we look at the size of the particles, the spaces between particles, gases have got large spaces between them compared to what? Liquids. Remember, we are talking about gases and liquids in diffusion because Diffusion only occurs in gases and liquids. So don't be surprised. We are not talking about what? Solids. All right, take note. All right, now checkpoint, checkpoint, checkpoint. What is diffusing? Do liquids or gas particles diffuse faster? Yes, send in your answers, my dear learners, so that we can move fast. Yes. Yes. My dear learners, send in your answers so that we can move fast. Waiting, waiting, waiting. I'm waiting. I know you are typing, so but make it snappy. Perfect. Perfect. I like the way you are responding today. It says what is diffusing, and B. Okay, somebody is saying yes. I don't want to read the answer. It says what is diffusing? Do liquid particles or gas particles diffuse faster? Yes, somebody got the answer. Yeah, so let your answers come in. All right. Perfect. I can see. All right. Perfect. That workers, that's good. I also have the answer from Princeton. That's good. Okay. But I want this explanation that I gave to you yesterday or previously. That was on Monday. But all what you are saying, you have an idea. But I want to see whether you can remember that. Let's we are left with 25 minutes, so let's try to finish up, and I can get time for you to play the Kahoot for you. Okay, all right, no problem. Let's go to the slide so that we can quickly make time. Those of you, you can mark for yourself. Yeah, you see, you got it right. So checkpoint one, the answers to the checkpoint questions are as follows. Diffusing is the movement of particles from an area of many particles to an area of fewer particles. Perfect. You can also say, yes, Musa, you are there. You are there. That's perfect. Yeah, so I just wanted to say that and you just brought it in. And then remember, we also said we can say diffusion is the movement of particles from a higher concentration to a lower concentration. Perfect. What we did, they are still fresh in your mind. Now, the answer to B, they are gas particles. So all of you, you got 4 marks, 2 marks for A and 2 marks for B. That's perfect. So let's go to the next. Let's go to the next. Then we looked at what? Change of state. So we said, let me go to this slide and then we can use that to explain. So we said substances can also change state, but it involves what? Energy. For matter to change from one state to another, its particles must gain or lose energy. The following diagram shows us that shows us to change how to change the state of a substance. It must either be energy added to heat it or to cool it. So let's look at this. We have got a solid when we add energy. So remember, when we add the energy is heat energy. Then when we add the energy, it changes to liquid. Then it changes to get on continual adding. And then when we come down, when we remove the energy, then the gas particles will change to liquid and then they will change to solid. That's basically what we're looking at. So melting and evaporation are processes that requires what? Heating, condensation, and freezing are processes that require what? Cooling. So take note. Okay, so I have already explained this basically. So let me jump. So send in your answers. What happens when a substance is heated? What do we call the change of state from a liquid to from a solid to a liquid? Send in your answer so that we can basically move on. When is all right? Let's see. Great. Melting, yes. Let's send in your answers for B. All right. I can see today your response is very 100%. What do we call the change of state? Lean, can you check your answer, Lean? I can see that one for Mosa also. Okay. Yeah. That's good. You are now talking now. You are now talking. That's good answer there. All right. So what happens when a substance is heated? Yeah, some of you gave the answer, it melts. What do we call the change of state from a solid to a liquid? What is that? There is a term for that. Okay, let's look at the yes. Now, what happens when a substance is heated? The substance changes states. Perfect. What do we call the change of state from a solid to a liquid? We call it melting. Perfect. All right. I'm seeing some responses here. Yes, yes. So it will change a state. Perfect. That's workhouse. It will change the state. Yes. Your first explanation, the answer was an 8. Very good, very good, very good. I like your response today. Yes, we also looked at what? Cooling. We looked at cooling, and then we said in cooling, I've also used that diagram to explain to you. Let me quickly go back there to that diagram so that you will understand it. Yes, yes. So heating and cooling all happen here. When we are changing the state, we need to add energy. When we are cooling, we remove the energy. You get that. So that's why I'm saying condensation, freezing are processes that require what? Cooling. So here, from the red arrow is telling me what? Melting. It is telling me what? Evaporation. Then the blue arrow, the first one, is telling me what? Freezing is cooling down. Yeah, that's cooling down. Then the liquid is what? Further, when it goes further, it becomes what? Freezing or solidification. All right. So condensation and freezing. Okay. So melting and evaporation. So the first one is talking about melting and evaporation, and the second one is condensation. Condensation and freezing. A gas to a liquid, when you cool it down, it condenses. Then from there, when it changes to solid, it becomes what? Freezing. So when we go back to the cooling, I'm not going to explain because I've just boxed everything into this diagram to explain that. Okay. Yeah, so this one I've explained that. This is the diagram also, just to facilitate more understanding. Gas, energy is removed, it becomes liquid. Energy is removed, it becomes solid. Again, energy is removed, it freezes. Then what? Condensation. So energy is removed. If it is a gas, it condenses. Further removal of energy, it is freezing or it becomes what? Solid. The process is called solidification. Now, yes. So yesterday I remember, or previously I remember this question. Checkpoint A was giving you a bit of a stress. Let's try to answer it. Okay, I want when it's 10 minutes to, then we will go and play Kahoot so that most of you, it's like if we don't play Kahoot, your day is not yet complete. So send in your answers. What do we call the process where water droplets form on the outside of a cold can of Coke? B, what change of state happens when a liquid is put in a freezer? Here there is something left out. What change of state will happen when a liquid is put in a freezer? Yeah, that's B. So let's see the answers coming. Perfect. I can see your answers. Let's see. Okay. Yeah, you are still not for A. It's still a bit of a problem or a stress for you people, but don't no problem. We will sort that out in the next slide for the correction. But B, you are almost getting it. All right, now let's see something. There is another one coming in. Okay, all right, that's great. Now let's go on to the correction. So you see, what do we call the process where water droplets form on the outside of a Coke can? Yes, some of you got that. Then what change of state will happen when a liquid is put in a freezer? Okay, the liquid will change to a solid. Some of you just said solidification. All right, you had the idea there. Okay, then we spoke about density. So I'm just going to explain this slide alone. And then from there, we try to go and play Kahoot. If we finish playing the Kahoot and there is time, and then I will give a summary. You remember we spoke about what? Density. And we said the density of a material describes the what? The amount of mass in a given volume of that material. So we said density is a property of material. And what is mass? Mass is a measure of the amount of matter that an object is made of. It is measured in grams or in kilogram. So there are 1,000 grams in 1 kilogram. That is a conversion factor. And then we talk about volume. All right. So volume is the amount of space an object occupies. It is measured in what? Milliliters or liters. There are 1,000 milliliters in 1 liter, and 1 milliliter is equal to 1 cubic centimeter. Mass and volume are physical quantities of a material. This means that we can observe and measure what? The formula for density. We can observe and measure them. So the formula for density is mass per unit volume. So we call it rho. This one that looks like P, you will see it very well here, is called rho. And the formula for calculating density is mass what divided by V. So that's why we were looking at the definition of mass and then the volume. All right, perfect. Now what I want us to do is, yeah, what is left is talking about density. Yes, so I've explained the important part of it, the definition, the relationship between mass and the volume, and then the formula and their unit of measurement. So if you wouldn't mind, I will quickly um, switch, and then we go and talk about what we play our game. I hope I'm taking the, yeah, let's go on. Okay, let me try to, just a minute. If you are seeing me, please respond. If you are seeing me, please respond for me to make sure that you have seen me. Not, yeah, not necessarily seeing me in person, but if you can see the slides, you can see me. All right, perfect. So let's get going. I'm going to teach now. So just a minute. It's loading up. 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 Oh, wait. I'm giving a different one. Sorry. This is grade 8. I'm giving you a different slide. Let me quickly make that up. Sorry. Let me quickly change that up. Yes. Sorry, guys. I was giving you grade 7. Sorry. But this is now the correct one. Yes, this should be the correct one. Perfect. Just wait for this to be green. Yes, it's green. Yep, this is the grade for you. So those of you who couldn't join, I hope you are fine now and your friends let you. Okay, this is our pin or code 74740002. Let me quickly write it for us. Okay, people are already joining in. People are already joining in. Yes. Is there anyone who is having a problem joining in? Is there anyone having a problem joining in? Preston is here. Han is here. Okay, perfect. Mosa is here. Katleho is here. Mr. Ellis is here. Sadie is here. Sadie, It's my first time seeing you here, or you have changed your name. Who is Sadie? International also here. Very good. We are starting. Take note. I start. Yeah. We are playing a 2-1-0. What is the density of water? Let's keep going. The faster you answer, then the higher the marks you get. Perfect. All right. Yeah, you all got it right. Most of you. So let's see those who got it. And the first person, yes. So all of you got it right, but in that order is Atlanta who answered first. Let's go to the next. Let's go to the next. I hope the time will be okay for us. How do you find density? Yes, we find density using mathematics. We find density using m over v, a question mark. Perfect. Yeah, we find density using the formula. All of you are getting that. Let's go on. As you can see, the scoreboard is getting thicker and thicker. All right, what is the unit for measuring volume? Let's go on. Is it liters? Is it in grams? Is it in meters? Is it in Celsius? Perfect. It's in liters. All of you got that fast, but five of you. Let's see. Let's see. Atlanta, and then Han is just reported that Han has the what highest answer streak of three, meaning Hans answered three questions and they are correct in a row. What is density? Okay. Ratio of how many particles a substance has in a certain amount of space. How much? Very good. Perfect. All of you got it except one. Let's see those who got it here. Yes, Natalia has overtaken Atlanta in the scoreboard. Let's see. Natalia has got what? A streak of four answers. Correct, meaning Atlanta, you didn't get this one right. That's why you have gone down. Let's go to the next. Are the books shown the same density? Watch the books and watch the values there and then see which one is the answer, the correct one. Are they of the same density? You have to look at the marks or the mass and the volume. This one is having 76 with a volume of 4. This one is having a mass of 98 with a volume of 5. So you need to divide mass over volume so that you can get your answer here. You have to do some calculation. Yes, you have got perfect. Yeah, 6 got this and 2. Thank you very much. You understand what we are doing. All right. Somebody who I also wants to overtake Natalie, who is still on the scoreboard. Density is a property of a substance. True or false? True. All of you got it before time. That's good. Let's go on. Yes, Atlanta has come back to the place. Yeah, he okay. TY just hit answer streak 3. It's reporting to me somebody just answered 3 questions right in a row. So let's get going. Which material has the highest density? Look at them. You look at the mass. Which one has got the highest density? Okay, the iron. Perfect. All right, all of you got that right? Yes, Atlanta is still on top, but Erin and Han have also answered faster. Let's go. Somebody will have to overtake Atlanta on the scoreboard. Let's see who is that. How do you calculate density? This is the formula there. How do you calculate density? Is it density is equals to mass times volume? Density is equals to volume divided by mass. Perfect. You can see that density is calculated by what? Using the formula mass divided by volume. Okay, 6 people got this one right. Yeah, Natalie and then Atlanta, they are busy changing positions here. Han is making a comeback with 3 answers in a row. Let's get going. Yes, question 5. What effect does salt have on the density of water? It increases the density, making water sink, decreases density, making water float, does nothing. makes it evaporate. Yeah, 8, 7, 6, 5, 4, 3, 2. Okay. All right. It increases the density, making water sink. Three people got this one right. Let's get going. Yeah. Okay. So the board is still the same thing. Let's see. Let's continue. What are the units we call? What are the units we use for density? Yes. Let's get going. Yeah. Let's get going. Perfect. Either is measured in gram per centimeter cube or kilogram per meter cube. That's perfect. So let's go on. Let's see the scoreboard. Mr. LS has come back with a streak of 4 answers in a row. Let's continue. We are in question 11. We are in question 11. Density is a conversion factor, true or false? Yes, all of you got that, right? Let's go on. Let's get going. Yes, let's see the scoreboard. Hey, between Natalie and Atlanta, Catlejo and Han and Irene. You must make sure that you overtake Atlanta and Natalie. They are busy changing positions there. I hope you catch them up. The formula or equation for density is, yes, perfect. It's mass over volume. That's correct. 5 people got this one right. Okay, so let's see. Somebody is having a what? A streak. Yes, Musa is making a comeback with 3 in a row, meaning Musa has answered 3 questions that are correct in a row. All right, let's move on. Density is determined by the what? Mass volume ratio. True or false? Perfect. That's true. All right. Hey, Natalia has overtaken Atlanta again, but nice. Han is also back with a streak. Let's continue. Which container has what? A higher density. Look at them very well. Perfect. The one on the right hand side. So let's see. Hey, yep. Yeah. The fight was between Natalie and Atlanta, but as well as Catlejo, Han, and Mosa. All your marks are very, very high. That's good. So let's view our report. Let's view our report next. Okay. Last question. Oh, last question. There is a last question here. Let's check it out. What does density do? Make things pull down, things go up because of density. Yeah, make things pull down. So let's see who is still on top. Yep, let's see. Catlejo got 12 out of 5, 15. Natalie 12 out of 15. Let's see. Lantler got 12 out of 15. But don't be surprised because if you answer fast, uh, you all got what? 12 out of 15. But the faster you answer, the what? The higher the marks you get. Okay, so let's quickly see the report in terms of percentage. Let's view the report. Let's view the report. Let's view the report. Let's view the report. We are viewing the report. It's just loading. It's loading. It's loading. Yes. Yes. We are viewing the report. Okay. Just a moment. It's loading up. Yep. Okay. All right. Just a moment. Yep. So we are looking for our report. We are looking for our report for today. Yeah. So we see players. We had got what 11 players today playing. Very good. Then you can see. So the competition was very keen, and I'm very happy for all of you. Today it has been an improvement, and luckily I have managed to play your Kahoot for you, and all of you. You can see your marks. You have done well, and then well done to everybody. I hope you enjoy it. You go. Oh, let's say the no problem next time. All right, you got out mistakenly, no problem. So I hope you did enjoy the game and the learning as well. Yeah, so keep well, enjoy the rest of your day, and hope to see you around. I hope you did enjoy it. Bye, and stay safe and be blessed. Bye from me.